Alright, here's a video going through the area of shaded regions, 6 different problems. Let's try them out. So, our first one here has a rectangle with a triangle inside. So we've got that situation going on. For the rectangle with the triangle inside, we want to find the shaded region. So just the big rectangle would be easy, right? 5 times 15. But we also have to remember to cut out that middle section. So when we're doing this, we're going to take the area of the big shape, subtract the area of the smaller one that we cut out. In this case, the area of the big shape is the rectangle, and the area of the smaller shape is that triangle. For a rectangle, all the parts that are shaded in black there, the area is length times width. So length and width are there, 5 and 15. 5 times 15 centimeters is 75. And centimeters times centimeters is square centimeters. So that's the area of everything including that middle triangle. But we want to cut that part out. So for the middle triangle, we need to know the formula there. The area of the small shape, the area of the triangle, is base times height over 2. In this case, the base is 3 centimeters. The height is 4 centimeters. Remember that those always need to be perpendicular to each other to help you identify them if you ever need to. So 3 times 4 is 12, divided by 2 is 6. So when we get back to our original idea here, big shape minus small shape, the big shape is 75 square centimeters. The small shape is 6 square centimeters. And if you subtract 6 from 75, you get 69 square centimeters. So that is the area that's shaded here, the big rectangle minus that white triangle. Let's try the next one. We have a semicircle with 2 semicircles cut out of it. And we only get one measurement, which seems like a bit of a puzzle. The only measurement they give us here is 16 meters from there to there. That is the diameter of the big circle. So there's like a big circle here that's been cut in half. And after that, two smaller circles have been cut out. So in this case, we've got the area of the big circle minus the area of a half small circle minus another half small circle. So this one and this one. But these two, given no further information about them, we have to assume are identical. So there are 2 of these that are the same. And a half circle here plus a half circle there should equal 1 full circle. So we're looking for the area of the big circle minus the area of 1 full small circle. The circle formula, if we're looking for area, is area equals pi r squared. We're given diameter and not radius, but we know radius is always half of the diameter. So 16 meters over 2 is 8 meters. So from here to here, that's 8 meters. And from there to there, that's 8 meters. Which means that for the smaller circle, the radius is going to be, again, diameter over 2. The small circle diameter is 8. And if we divide that by 2, we get 4 meters. That's the radius of the smaller circle. So if we come back to our main idea here, area of the big circle minus area of the small circle, we have to pay attention. We paid attention to the little one and said, okay, 2 half circles make 1 little circle. But the big circle is only half of a big circle. So we need to modify our formula to be just half. So for the big circle, area is equal to pi r squared. But since it's only half a circle, we can divide that by 2. that dividing by 2 is taking that big circle and chopping it in half. If I divided it by 4, I would be dividing it like this. If I divided it by, I don't know, 8, I'd be dividing it into 8s. But I'm only dividing it here into 2. So for the big circle, that's pi times 8 meters squared, and then divide that by 2. For the smaller circle, put that over here, the area is pi r squared. They're each half circles and there's 2 of them, and that's why we just said it's like one whole circle. So that is equal to pi times the small radius, 4 meters squared. If we finish this off for the big circle, if we take 8 and square it, that's 64, multiply it by pi, and divide it by 2, we get 100.53. It keeps going after there, but we'll just stop at 100.53 meters squared. And for the smaller circle, if we take 4 and square it, and then we multiply by pi, we get 50.265. meters squared. So the area of that big half circle here, without these things cut out of it yet, is 100.53. And the area of this small half circle plus that small half circle, so one whole big circle, is 50.265. If we subtract them, (100.53 meters squared minus 50.265), we get 50.265. We get exactly half. We've cut out exactly half. And I think that makes sense. So maybe we would round this to 50.27, or maybe we would round it to just 50. Depends on what they ask us to round to. So here, somewhere around 50 meters squared is exactly half of this bigger circle, because we're cutting out 2 circles with radius that are exactly half of the radius of the big circle. So it should be half as big, and I think we can see here that it is. I'm going to stop this video here just to do kind of 3 and, no, I'll do this third one, and then we'll do 3 and 3. No, changing my mind again. Yeah, we'll stop here. That's already almost 8 minutes long, and I'll work on the next ones in the next video.